Your nose knows something about your garden that your eyes will never see. Right now, buried under your tomatoes, a chemical conversation is happening between billions of bacteria, fungi, and microscopic animals. Every one of those soil organisms is leaving a smell signature. Peer-reviewed microbiology has now confirmed that the smell of your garden soil is a direct readout of its biological health. The Romans knew this 2,000 years ago. Modern gardeners have forgotten it. In the next few minutes, I want to give you a brand new sense for understanding your garden. Let me start with the smell you already love. Go outside right now, grab a handful of good compost, cup it close to your face, and breathe in. That sweet, earthy scent, the one that smells like a forest floor after rain. That is not a vague, pleasant thing. That is a specific molecule called geosmin. And the story of geosmin is one of the strangest and most beautiful things in all of soil science. Geosmin was first isolated in 1965 by two Rutgers scientists named Nancy Gerber and Hubert Le Chevalier, working with a bacterium called Streptomyces griseus. The name literally means earth smell. Here is the part that blows my mind every time I think about it. Your human nose can detect geosmin at concentrations of around 5 parts per trillion. That is like dropping a single teaspoon of geosmin into roughly 200 Olympic swimming pools of water and still being able to smell it. We are more sensitive to this one molecule than sharks are to blood. Our sensitivity to geosmin is not casual. It is ancient, deeply wired, and we share the same dedicated olfactory receptor with dozens of other mammals. So why does your healthy soil smell of it? This is where the research gets wild. A paper from 2020 published in Nature Microbiology finally answered a question scientists had been chasing for decades. Streptomyces bacteria live in healthy soil, decomposing organic matter and cycling nutrients. When a colony is ready to reproduce, it forms spores. And right at the moment of spore formation, the colony releases a burst of geosmin. The smell is a chemical advertisement to tiny soil arthropods called springtails. The springtails come running, they eat the bacteria, and they carry the spores away on their bodies to new locations. Your soil does not smell good by accident. It smells good because a 450 million-year-old ecological partnership is happening right under your fingertips. When your garden smells of a forest floor, what you are actually smelling is bacteria successfully reproducing in a working soil food web. And that smell after it rains? The one they call petrichor? For decades, people assumed the rain itself was producing the scent. Then, in 2015, two MIT researchers named Young-Soo Jung and Cullen Bowie used high-speed cameras to record what actually happens when a raindrop hits soil. The raindrop does not just splash, it traps tiny air bubbles inside the porous soil surface. Those bubbles burst upward a fraction of a second later, launching aerosol mist into the air. And inside that mist is geosmin, other volatile compounds, and even live soil bacteria. One raindrop can aerosolize thousands of bacterial cells. Globally, rainfall sprays an estimated 10 to the 16th bacterial cells into the atmosphere every year. The smell of rain is not rain, it is your soil breathing out. Now here is where I want to give you the actual diagnostic tool. Because while the earthy smell is the signature of a working soil, there are 5 other smells that are warnings, and every one of them is a specific chemical telling you a specific problem. The first warning smell is rotten eggs. If you dig into a bed or open a bag of potting mix and get hit with a sulfur stink, your soil is in a genuine emergency. That smell is hydrogen sulfide gas, and it is being produced by anaerobic bacteria called sulfate reducers. These bacteria only wake up when oxygen is gone. Research from North Dakota State Extension shows that in a waterlogged raised bed at summer temperatures, oxygen can drop to root-killing levels within 48 to 96 hours. Hydrogen sulfide does not just smell bad, it is directly toxic to root tips. It forms black iron sulfide coatings on root surfaces that block further oxygen uptake. And it triggers a cascade called autumn decline in rice paddies where root crowns rot and plants topple over. If you smell rotten eggs, your worst instinct is to add more water. Do not do that. What you need is oxygen. Broad fork the bed, improve drainage, add coarse organic matter like wood chips, and in severe cases, let the soil dry out before you replant. Recovery usually takes several weeks to a full growing season. The second warning smell is ammonia. It is that sharp sting that reminds you of window cleaner or cat urine. This one catches a lot of gardeners off guard because most of us assume an ammonia smell means nitrogen-rich soil. It is actually the opposite. An ammonia smell is the sound of your fertilizer leaving the building. Research from the University of Wisconsin and Mississippi State Extension shows that when fresh manure or urea fertilizer hits a warm, alkaline soil surface, the nitrogen converts to ammonia gas and floats away. At soil pH above 7 and temperatures above 15 degrees Celsius, you can lose between 10 and 40% of the nitrogen you applied within just 72 hours. So every time you walk into a garden that smells aggressively of ammonia, you are literally watching money evaporate. The fix is simple. Cover fresh manure with a layer of straw or finished compost immediately. Water it in with at least a 1/4 inch of irrigation. If your compost pile smells of ammonia, it is too nitrogen heavy. Add dry carbon. Shredded leaves, wood chips, cardboard, all of these will shut it down within a few days. If you are finding this useful so far, do me a favor and subscribe. I break down the science behind practical gardening every week, and there is a lot more where this came from. Now let me show you the sneakiest warning smell of all. The third warning smell is a sour vinegar scent. This one is dangerous because gardeners almost always mistake it for something good. When your bagged potting mix smells sharp and fermented, or your compost pile smells vaguely of sourdough starter, your instinct says that smell's alive and must be working. It is not. That smell is anaerobic fermentation. Clostridium bacteria and lactic acid producers are creating organic acids, acetic acid, butyric acid, and propionic acid. Peer-reviewed research going back to Drew and Lynch in 1980 confirms that these short-chain fatty acids are directly phytotoxic to germinating seeds and young roots. Plant a transplant into sour-smelling soil, and you will see stunted growth, yellow leaves, and slow establishment. The soil is not active, it is spoiled. The fix is the same as for any anaerobic problem. Turn it, aerate it, add dry browns, and give it 2 to 4 weeks to shift back toward aerobic dominance. The fourth warning smell is genuinely putrid. Think sewage or decomposing protein, the kind of stench that comes from putrescine and cadaverine produced by proteolytic bacteria. This is a food safety flag. Not because the smell itself carries pathogens, but because the conditions that produce putrid smells overlap with the conditions that favor harmful bacteria. Remove the source, aerate the bed, and if the smell persists, get the soil professionally tested. The fifth and most serious warning smell is chemical or petroleum. A solvent whiff, a gasoline note, anything that does not smell biological signals exogenous contamination, and it means stop growing food in that spot. Stop immediately. Polycyclic aromatic hydrocarbons and petroleum residues can persist in soil for years or even decades. This is the one smell where your nose is telling you to call in professional testing. And here is the most important thing I can tell you about smell and food safety. The dangerous pathogens that gardeners actually need to worry about, E. coli O157 and Salmonella, the nasty ones, are completely odorless at infectious doses. Heavy metals like lead and arsenic are also odorless. Your nose is an excellent diagnostic tool for oxygen levels, nitrogen cycling, and contamination with chemicals, but it is not a pathogen test. For pathogens, rely on proper manure composting, the 90 to 120-day waiting period between raw manure application and harvest, and when in doubt, a laboratory. Before we talk about the Romans, let me show you how to use your nose on the one place every gardener has direct control over: your compost pile. Cornell University maintains a compost odor monitoring guide used by commercial composting facilities nationwide, and the principles scale down perfectly to a backyard bin. A healthy, active compost pile has a mild, earthy smell with a hint of warmth, almost like freshly baked bread. When your pile shifts into the thermophilic phase, where internal temperatures climb above 55 degrees Celsius, the smell intensifies into something rich and almost mushroom-like. That is your signal that beneficial fungi and heat-loving bacteria are breaking down organic matter correctly. When the pile finishes and enters the curing stage, the smell softens back into that classic earthy forest floor scent. That is the signal it is ready to use. If your compost smells of ammonia, your carbon to nitrogen ratio is tilted too far toward greens. Fix it by layering in dry browns. If it smells of rotten eggs, your pile is too wet or too compacted. Turn it and add coarse material. If it smells sour or alcoholic, you have the grass clipping disaster: compacted wet greens fermenting anaerobically. Pull the pile apart, mix in dry material, and it will correct within about a week. Every single one of these problems is diagnosable in 3 seconds with your nose. Now let me connect all of this to something beautiful. The Roman agronomists Cato, Varro, and Columella, writing between 160 BC and 65 AD, all included soil smell and taste tests in their farming manuals. Columella, in his book De Re Rustica, devoted entire passages to testing soil for sourness and sweetness. They had no microscopes, they had no lab tests. They had their noses and 2,000 years of accumulated peasant wisdom. And they were right about every single category. Sour meant anaerobic. Sweet and earthy meant fertile. Bitter meant exhausted. Modern soil science, with gas chromatography and DNA sequencing and volatile organic compound profiling, has essentially spent the last century confirming what Roman farmers knew by sticking a clod of earth under their nose. So here is how you use this information right now, today. Go out to your garden, pick one bed, scrape back the mulch, and dig down about 4 to 6 inches. Scoop a small handful of soil. Cup it close to your face and breathe in. One smell. What do you get? If it smells sweet, earthy, like the floor of a Douglas fir forest, celebrate. Your Streptomyces bacteria are reproducing. Your Actinomycetes are cycling nutrients. Your soil is alive. If it smells of anything else, you now know exactly what to do. If you smell rotten eggs, the soil is waterlogged and needs broad forking and better drainage. If you smell sharp ammonia, cover the soil and water it in to stop nitrogen loss. If you smell sour vinegar, turn the soil and add carbon to rebalance it. If you smell putrid, remove the affected material and aerate the bed. If you smell chemical or petroleum, stop using the area and get a professional lab test. Do this once a week in each bed for a single growing season, and I promise you will know your soil better than nearly every gardener you know. Smell is not mysticism. It is peer-reviewed microbial chemistry that happens to be free and instant, and sitting right between your eyes. Next week, I am breaking down what actually happens inside your raised bed during a heavy rain. The underground chemistry nobody ever shows you, and why some beds recover within hours while others go anaerobic for weeks. If you want to see that one, hit subscribe now so you do not miss it. I will see you in the next one.